This is an enzyme. An enzyme is a protein that acts as a catalyst to speed up chemical reactions. On an enzyme, there are two major parts. There's the active site, which is outlined in green, and then there's the allosteric site, which is everywhere but the active site, so the pink area. So what happens to an enzyme is that it combines with something called a substrate. The substrate is the reactant in a chemical reaction. What happens is that the substrate combines with the enzyme at the active site, right here. After the chemical reaction has been done, the substrate is put into two different products. After that, or another time during a process, there are things called inhibitors that affect an enzyme. Inhibitors are things that slow down a chemical reaction or prevent it from happening. So, there are two examples of inhibitors, competitive and non-competitive. A competitive inhibitor combines at the active site. So the substrate can't combine with the enzyme. Another type of inhibitor is the non-competitive inhibitor, and it combines at the allosteric site, which is anywhere but the active site. But it still prevents the enzyme, or the substrate, from binding with the enzyme.
Okay. So, can you give me an example of a substrate?
An example of a substrate would be lactose, sucrose, maltose, stuff like that.
Okay. And what about an example of an enzyme?
That would be lactase, maltase, sucrase, anything that ends in ASE.
Okay. And the enzyme itself, so you gave a specific enzyme, specific substrates, like lactose and lactase. Are they, like in an enzyme, a lactase enzyme, can it bond with like sucrose, or does it have to be like a specific match?
Every enzyme has a specific shape, and it can only bond with specific substrates. So it can't go around like a sucrase enzyme can't go around bonding with lactose. It's the shapes match up with each other.
Okay. And so the enzyme, once it goes through that bonding, is it done, or is it like leave the body, or what happens?
Actually, once the substrate leaves the enzyme can go and find other substrates that have the same shape as the active site.
I see. Thank you. Go.
There are other ways that enzymes aren't able to function besides inhibitors. There is temperature, pH, substrate concentration, and enzyme concentration. I'm going to show you a real-life example of how temperature affects enzymes. So here in the bowl we have butter, or also known as our enzyme, and I put it in the freezer for a while just to show when it gets cold that it's very stiff. I can't move it. The shape doesn't change shape. It's the same shape. So in your body, enzymes aren't able to change shape if cold has been applied to it, and they aren't able to connect with the substrate. Now I'm going to show you what it's like when I apply heat to the butter. Now I've applied heat to the enzyme, as you can see. It has no longer kept the cold shape it has. It's no longer a regular shape of an enzyme. It's all mushy and lost its shape. The enzyme has been denatured. And in real life, an enzyme cannot work if the body is over 40 degrees Celsius. The enzyme denatures like so and can't keep a final shape.